So good afternoon, everyone. Thank you for joining us. We will start in a couple of minutes, give people a chance to join, and then we'll be underway. So good afternoon again, everyone. Thanks for joining this Harting and Mauser webinar today. My name is Mark Patrick. I head up technical marketing for Mauser in EMEA, and joining me today is Marianne Dunker from Harting, and he's going to present on digitalisation processes for Industry 4 and Industrial IoT. For those not familiar with Mauser, we are a fully authorized global distributor of semiconductors and components, focusing on the newest products from over 1,100 manufacturers, of which Harting is one of our leading connector manufacturers, and we have around 19,000 Harting parts in stock available to ship. Just a little bit of housekeeping before we get started. Please ask any questions you may have on the presentation using the Q&A button you'll see below, and we will answer as many questions as we can at the end of the presentation. If you have any technical questions around the webinar audio or webinar functions generally, please use the chat function and someone from Mauser will help you as soon as we can. But without any further ado, let me hand over to Marianne.
Yeah, hello and welcome everyone to our today's webinar. Thank you, Mark. Yeah, as Mark already mentioned, so we will focus in this webinar on the new technology, single pair Ethernet, which is also known as the enabler for the industrial Internet of Things. And so the agenda for our webinar looks as it follows. So I want to start and give you an overview about this new technology, what it's about, what is the goal of this technology, and what is the idea behind. So what is the status about the standardization and which standards are necessary for such a new technology? The topic of remote power, so in the sense of one cable automation. Yeah, so we as Harting, as a connector manufacturer, so what is our purpose on this technology? So on which have we focused? The roadmap, so what are the upcoming products? And at the end, I want to give you or introduce the single pair Ethernet industrial partner network. So let's start with the technology itself. So, and I want to first show you the idea of single pair Ethernet. So what is it made for? And therefore, we take a closer look on the automation pyramid, which I think is very well known in the industry. So, and if we take a closer look inside this pyramid and look how industrial communication works today, so Ethernet is already used in the upper levels of the industry or in the environment of the factory. So, but we have a gap in the field level, and so there we have a really fragmented situation. So we have a lot of different proprietary bus systems, we have analog system, and maybe a small amount of industrial Ethernet protocols. And so the problem is that all these different protocols are not compatible to each other, and we need a lot of effort, such as gateways, to translate all these different protocols into each other and make the communication work. And so now the idea is of single pair Ethernet is to extend this Ethernet structures from the upper levels to the field level and bring Ethernet to every sensor and actuator in the field level, and to enable the term we know, sensor to cloud automation. So to bring really have to generate a continuous system based on Ethernet. So, and this is the main focus of single pair Ethernet in the industry. So, and to make this happen, or to make this a reality, so we need a couple of different things, because single pair Ethernet is a new physical layer based on 2-wire Ethernet. And that means that we can't use the existing network infrastructure, and we need everything new. And therefore, we have created this single pair Ethernet ecosystem, which shows on the different semicircles all the different aspects we need to bring Ethernet to the industry. And if we take a closer look on the first semicircle here in the middle, which is called SPE technology. So that means in the first step, we need the technology itself. And and after we have developed or founded this new technology, we need a lot of different standards. So because standardization is a very important topic for new technologies. So because it creates clarity and future proofing and future security, so that everything around the network infrastructure is clearly described. And there we have a couple of different standards, starting with component standards, such as for the raw cable or for the connectivity. We have cabling standards, so how the network infrastructure must be designed. We have test standards. We have standards for remote power and so on. And after all these standards are in place, so the component manufacturer on the third semicircle can start to develop new SPE capable components, such as MACs, PHYs, magnetics, cables, connectors, and all this stuff. And so then the device manufacturer can start to develop SPE capable devices, such as switches, sensors, actuators, controller. And when we have all these devices ready on the market, then we can start to serve the different applications. And as you can see on the last semicircle, on the application semicircle, you can see that we have not only the industry on that semicircle, so we have automation, we have transportation, we have robotics, we have mobile working machine and smart farming. And the reason is why we have such a big bunch of different applications is that single pair Ethernet could really be a groundbreaking new technology and new invention for the industry, and can bring Ethernet to every application where high data rates are needed, where sustainability is needed, and so where Ethernet is not been used today. And as I mentioned, so it is a new physical layer. And so what does it mean? So how it looks like compared to well-known Ethernet technologies. And so today we know two different Ethernet technologies. On the one hand, we have fast Ethernet, which transmits Ethernet via 4 wires or 2 twisted pairs. So, and then we have the well-known transmission rate up to 100 megabit per second, up to transmission length up to 100 meter. And we have gigabit Ethernet with 8 wires or 4 twisted pairs up to 10 gigabit per second and 100 meter. And so the new thing on single pair Ethernet is, as the name already says, we only have one twisted pair, only 2 wires. And right now we have a variety of different IEEE standards, so different transmission standards from 10 megabit up to 10 gigabit per second. And they vary in the transmission lengths. But which transmission standards are available, I will show you and explain you on the next slide. And so now we will switch to the standards portion of this webinar. So in here you can see the overview of all the available IEEE 802.3 standards. So for those who don't know, so the IEEE is the International Standardization Committee for Protocols. And in the 802.3 section, everything is described, or every transmission standards are described, which are copper-based. If we compare it or take, for example, wireless, so they are in 802.11. And so this is based on copper. And we have 4 different standards. So if we start with the first one, so the 10 base T1, so which is on the bottom. So we have on the x-axis, we have the transmission length, and on the y-axis, we have the transmission speed. And so the first standard is 10 megabit per second up to 1000 meter, so up to 1 kilometer, which is a very big transmission length. And 10 megabit is more of the most bus protocols can deliver today. But so this is a point-to-point connection, so typical Ethernet star topology. But this standard has also a second standard inside, which is called multi-drop. This is a point to multi-drop connection where you can daisy chain devices. You can do it up to 25 meters with at least 8 nodes. So this is very unique for single pair Ethernet to have such a bus or line structure in an Ethernet network. And then we have the 3 other standards. So we have 100 megabit per second up to 15 meter. We have 1 gigabit per second up to 40 meter. And then we have 3 standards included in the multi-gig base T1 standard, 2.5, 5, and 10 gigabit per second. So now you may ask yourselves the question, so why does the transmission length vary so between the standards? And that is because of the origin of single pair Ethernet. It originally came from the automotive industry, and they started in 2015 with the 100 megabit standard, and inside a car, 15 meter may be enough. And after that, so the industry jumped on this single pair Ethernet train and recognizes the potential of it and started to support this standardization and this technology development. So that's why we have this 40 meter in the 1 gigabit standard and this 1000 meter on the 10 megabit standard. And so, so as I shown on the previous slide, so we all know in our industry the 100 meter, and currently, the committees are working on the extension of this short transmission lengths to extend them up to at least 100 meter. And so also the standards are very challenging for all the manufacturer of single pair Ethernet components or devices. So you can see it on the right-hand side in blue, so the bandwidth. So for example, we have for the 10 gigabit per second standards, we have a bandwidth or frequencies up to 4 gigahertz. So if we compare that with a standard Ethernet Cat6a, so we have a bandwidth of 500 megahertz. So it is 8 times higher. So it's quite a lot, and it's very challenging, and the requirements are much higher than we know it from today's technologies for single pair Ethernet. Yeah, when we talk about new transmission technologies, we also have in mind this term of one cable automation, to have only one cable where we can transmit data and power simultaneously. And we know from the existing technologies, power over Ethernet, in different variants. So, and there is a similar technology for single pair Ethernet, which is called power over data line, or short POODLE, which is also already standardized in the IEEE. And the special thing about it is that we have, compared to PoE, we have 3 different voltage levels. We have a 12-volt level, a 24 and a 48-volt level. So, and with PoE, we only have a 48-volt level. So, and there we also see the influence of the industry and the automotive sector. So, and with power over data line, we do not need a DC-DC converter like we know it from PoE, because we have the different voltage levels and can use the common 24-volt level for the industry. There are different possibilities of powering devices remote, such as hybrid or direct power. So hybrid, we will take a closer look at some slides later. So direct power, okay, we always need a separate power line, so which is not our focus today. And what did Harting in all this process of standardization and the development of single pair Ethernet? So our core competence is connectivity. And so we are active in the standardization since 2015, 2016, as the first SPE standards came up. And so then also the question raises of a connector for single pair Ethernet. And we developed the connectivity standard IEC 63171-6 together with other companies. And so this is also called T1 Industrial for single pair Ethernet. And so special about this connector standard is that it was the first published connector standard for industrial single pair Ethernet connectors. So in terms of standardization, it is called MITE 3, which is the highest class for harsh environment applications. And a big value is that this standard covers all variants from IP20 up to IP65, 67 in one standard. And it guarantees a really future-proofing design and compatibility, because it covers also all the data rates which we have seen on the previous slides, from 10 megabit up to 10 gigabit per second, which means so you can operate all the different standards with only one connector, and you don't have to care about which transmission speed the device uses. So you can see some pictures of the different variants of the connectors. So we have an IP20 variant for cabinet applications. We have different M8 and M12 versions, which are very common in the market for industrial applications, with different locking mechanisms like the well-known screw connection or push-pull outer locking. And there we see for the first time one special connector in this standard, the M8 hybrid, which has 2 separate power pins to transmit more power, or a higher amount of power for bigger sensors or actuator applications. But I will also show you some slides later what's going on with this hybrid stuff, which might be really interesting, I think. And this standard was already published in January 2020, so more than 2 years ago. So, and it's quite famous and well known in the market. But standardization was also an important topic on the second semicircle of the ecosystem. And so we as Harting has developed this connectivity standard, the -6, but this is more or less only a component standard. And there is only a value for the users and for the customers when we have a whole standardization landscape and all these different standards work together, so that we have references between this between the standards, and so that we have a very coherent landscape. And therefore, I brought you the overview about all the important standards we need and we already have in place for single pair Ethernet. So there are, on the one hand, the protocol and technology standards made by the IEEE, so different component standards, cabling standards. So there we have the ISO-IEC, which publishes cabling standards for the whole world, and the TIA, which focuses with cabling standard on the North American market, so USA, Canada, and Mexico. And there were international selection processes for a connector, so for the components for single pair Ethernet. And all these different standardization committees voted for the -6 connector standard and choose this one as the standard mating phase for single pair Ethernet. And I've also mentioned the references here below. So for example, we have a maybe use in the IEEE, we have a shall be used and a should be used in the ISO-IEC, and it should conform to IEC 63171-6 in the TIA. So the wording differs a bit because this is standardization language. So, but we have a clear commitment from all the standardization committees so that the infrastructure is clearly described and everyone can build up networks according to these standards. Yeah, if we take now we want to take a closer look on the technical specification of the IEC 63171-6 connectors. And so therefore I will present you the mechanical performance and the electrical performance of these connectors. So on the left-hand side, you can see some variants which are already available on the market. So we have chosen the typical Ethernet interface design for these connectors. So that means the plug or the cable connector is designed as a male version and the PCB side as a female version. Yeah, we have different locking mechanisms for this with high mating cycles, more than 1000 for the IP20 version and 500 for the IP65-67 versions. Yeah, we can offer different IP ratings from IP20 up to IP65, IP67. So you can see on the pictures so that we have always the same mating phase. So it's because it's a modular system, which is completely designed out of stainless steel. So which makes it very modular and robust and also offers a good shielding. So right now we can cover the wire gauge from 28 up to 22, have a temperature range from -40 degrees up to +85. And the whole system is shock and vibration proof according to the IEC 61373. And this is the category 1B standards of the railway standards because we made the experience in the past. So that if we met this shock and vibration standards from the railway market, so it really good confirms also the requirements of the industry because we are also very active in these markets. Yeah, electrical performance, as I already mentioned. So the whole system is designed for transmission speeds up to 10 gigabit per second. So the main idea is to have one connector for all different standards. Yeah, rated voltage, 60 volt. So the rated current, so it depends on the wire gauge which is used, but we have 4 amps at 60 degree with wire gauge 22. We have a voltage proof pin to pin, 1000 volt DC, and pin to ground 2.25 kilovolt DC. And this requirements came from the IEEE 802.3 CR. So there are requirements for network devices are defined. And yeah, because of the stainless steel design, we have a 360 degree shielding. And yeah, as we've already heard, so it means E3 out of -3 for the EMC resistance. But beside the technical advantages single pair Ethernet offers, so we have a continuous system. So we have all the possibilities which are more or less software based because high data rates, we can get more data out of our sensors. We can transmit the data directly from the edge to the cloud and all this stuff. So we have also some size advantages of single pair Ethernet. And so this is a very good example on the right-hand side where you can see an interface with single pair Ethernet and and an interface based on RJ45. And you can save approx 50 to 60% on the PCB if you're using single pair Ethernet without Poodle, because right now the Poodle components are quite big. So this will change in the future, but right now we are in a very early stage of this technology, so not everything is so optimal. But you can see that you can save a lot of space, and that is maybe mainly because of so we have a lot of components on the PCB which are related to the number of transmission pairs we have. So such as the magnetics and the common mode choke. So there we need one magnetic and one common mode choke per transmission pair, per twisted pair. And if we can reduce from 8 to 2 wires, so we only need one magnetic and one common mode choke, and then we can save between smaller cables, smaller connectors. We can also save a lot of components on the PCB, which makes or can lead to smaller devices in general, or to a higher packaging density, depends on what is needed. So, and then you can also see the volume reduction below. So we see a multi-port version, a concept for a multi-port version. So where we can see the size of a common or usual multi-port based on RJ45 and beside on single pair Ethernet. So where you can see you can really save a lot of space in the whole device. And single pair Ethernet is not only a new physical layer, it's not only a connector or not only a cable with a reduced amount of wires. So it's really a whole system which brings a value to the users. Yeah, and it goes on with the IEC 63171-6. So this is a second connector standards which is currently developed in the IEC. So, and this standard focuses on hybrid M12 connectors. So you have seen in the -6 is the first M8 hybrid connector included. So, and here we have 7 different codings for 2-phase and 3-phase systems and applications. So we have one signal pair or data pair, and we have separated power contacts for voltages up to 360 volt and currents up to 16 amps. And also this system is specified for MICE 3 harsh environmental industrial applications in IP65 and IP67. So this standard will be ready somewhere in Q1 or Q2 2023. So also this standard is more or less published. Yeah, so now we will take a closer look on the roadmap. So which products from Harting are already available and will come up in the next months. So we have already launched in 2020 the IP20 version, field installable with crimp contacts and as overmolded patch cords. And we also have the first angled jacks in IP20. In the first quarter this year, we have launched M12 versions, field attachable with crimp contacts with screw locking, and 3 different PCB jacks, 2 vertical ones in different heights for different market standards, and an angled one, and 2 different panel feed throughs, so with screw and push-pull locking. And in Q4 this year, a number of products will be added to this portfolio. We will launch the M8 hybrid version, cable side and device side. We will launch SPE capable or Ethernet capable terminal blocks, especially for low speed applications. And we will also launch the M8 2-pole screw connector in M8 form factor as overmolded cable assembly and 2 device sides. And on the right-hand side, you can see the product outlook. So we have a lot of different products in mind: IDC termination, female cable connectors for couplers, different hybrid versions, SMT contact, multi-port versions. So, and all in all, we can say all the different products and versions we know from today's RJ45, M8 or M8, M12, DNX coded, all these necessary products will be added in the future to this portfolio and will also be available for single pair Ethernet, so that we have in a couple of years, so the whole range of products which are needed for the industry. And yeah, so beside that, we also have launched the first active devices. So we have launched the first single pair Ethernet capable media converter and switches for 100 megabit transmission. And we will also launch this year 1 gigabit switches and switches with M12 locking. And yeah, last but not least, I have shown you the SPE ecosystem. So with all the different components and aspects which are needed to bring such a technology to the market. And so no company on the world has the power to do this alone. So you need strong partners, you need a strong network to cover all the different areas of the ecosystem. And therefore, we have founded the SPE Industrial Partner Network in 2019 with 7 founding members. And this is a registered association based on German law, which celebrates this year the 3rd anniversary. And yeah, right now we have more than 50 members worldwide. I guess it's 57 members till today. So you can see we cover, so they came from all over the world, from Americas, from Asia Pacific, and from Europe. So you can see some very big names beside Harting. So it's not only connectivity and not only cabling. So you see a lot of companies which are doing something different. We have, for example, Softing for measurement equipment and test equipment. We have company Hirschmann for active devices such as switches, company Dehn for surge protection. So we have companies from all over all areas of the ecosystem to develop this technology, to make it more easy for the users and for the customers to get into this new technology, to be a single point of contact for them, to support the market, and yeah, to make this vision which we have of single pair Ethernet for the future a reality. And yeah, so this is the end of my presentation. Thank you very much for your attention. I hope this was a good overview for you in the first step of single pair Ethernet, and I hope it was really interesting for you.
Thank you very much, Marianne. Exactly as you described, I think an excellent overview, and really interesting to see all the partners there in the network as well, because I think, as you said, the ecosystem is very critical, really, to make it happen. There's a few questions coming, and what's interesting, I think, is after all that effort of moving to single pair Ethernet, somebody's asked if conventional Ethernet cable can be used with conventional sockets for SPE. So what are your thoughts on that?
Yeah. So this is a very critical point and a question which is asked very often. So we can't guarantee that this works, because I've shown you the slide with the requirements of single pair Ethernet, and that the frequencies increases for the single pair Ethernet standard compared to standard Ethernet. So it might work for the slow speed standards, such as 10 megabit per second, that a channel with reusing the existing network infrastructure might work. So, but yeah, this is really something which has to be tested individually if the channel works. So and otherwise, yeah, we have new connectivity, we have new cables, especially designed for this high frequencies. Yeah, so this is really a case-to-case decision, and yeah, so we can't give a general information about that.
Right. As you say, it seems that it might be useful for the sort of more basic applications, but higher speed. Yeah. understood. Thank you for that. Another one is around standards and technology. So it clearly, there are cost savings on cabling and also PCB area and physical size. What about costs of production of the sockets and plugs? So will they be close to RJ45 costs, which I assume by the sheer volume of those that are made, that is pretty low?
Yeah. So this is clearly the target, so that that the costs of the infrastructure decreases in the future. So right now, because the volumes are not there, so it's of course more expensive than the RJ45 infrastructure. But so if you take a close look on the whole system, so it's not only connectivity and connectors and all the stuff and cables, so you have really to keep in mind the whole advantage of the system. And so we have the information when we're talking with cable manufacturers that if the technology is in the market, and so we have the volumes, so that connectivity and cabling can be around 30 to 40% cheaper than today's cabling. Right.
And there's a third question actually, which is really asking the same question, but I think it's economies of scale. But assessing the overall requirements, assessing the application as a whole, I think is probably a more effective way to look at it than just sheer plug, socket and cable costs. Another question on, because we're talking about single pair, we're also talking about unshielded twisted pair from time to time. What about noise immunity? I think you mentioned the mice standard once or twice, but you see that unshielded twisted pair might present some challenges there. Any comments on that?
Yes, of course. So so the main standards, so all the point-to-point standards are specified with shielded cables, so the high frequency standards. So maybe I can go back to the slide here, so that I can show it. So the slow speed standards, so T1S and T1L, so they specify unshielded twisted pair protocols or standards, because we have only 20 megahertz. So, and then the influence of crosstalk and so of EMC influences are parasitary effects are not so high, but in general it's a shielded system.
Okay, good. A couple of other questions. So will SPE replace standard Ethernet based on RJ45 or M12? And I guess this is the ambition, right, to move to a complete single pair.
So single pair Ethernet has the potential to replace infrastructure based on M12 or RJ45, but in the first step it's also an extension of existing infrastructures to bring. So the idea is to bring Ethernet to the field where Ethernet is not really common today. And so we will have a coexistence, because the installed base of RJ45 is so huge. So I'm not sure if any standard or any technology can replace it completely, but we will definitely see some areas where this will happen.
Right. And I think your last slide talked about switches and media converters that will kind of join the two worlds together.
And especially right now in these times where sustainability is becoming a more important topic, and so in all areas, not only copper or plastics and all this stuff. So there SPE will also offer a big opportunity to save a lot of resources in the future.
Yeah. Do you also think, there's another question here about transmission standards and what they might look like in the future? Do you think the standards will still be extended or unified? And now that, because currently they still vary, depending on standards. So what are your thoughts on that?
Yeah. So there's right now one project ongoing in the IEEE for the 100 megabit standard. So it is called extended reach, extended speed. And they deal with to extend the standard up to a couple of 100 meters. So they're talking about 500 meters. So to bring really a value to the industry, to have more than this common 100 meters, which we know today. And yeah, if this is successful, so this will be probably successful, they will adapt this to the other standards, I'm pretty sure.
Right. And of course, there are some other protocols as well to consider on there. So things like Profinet, can they be transferred via SPE?
Yeah, yes, of course. So because single per Ethernet is in a first step a new physical layer, and so other protocols can be transmitted over SPE. And we know from some user organizations which are already investigating this to transmit their protocols over single per Ethernet and to adapt this as a new physical layer. And yeah, it's possible.
Okay, excellent. So that's all the questions we have for today's webinar. Thanks again, Marianne, for an excellent presentation.
Yeah, thank you for having me.
Really good overview. Thanks to everyone for joining. Questions will be answered in writing and will be made available to all participants. So, and also if you want to watch the webinar again or share it with others, it will be available on demand soon. Finally, I would ask that as there's a short survey coming up, we'd be really grateful if you could provide some feedback to help us make our, improve our webinars in the future. And or even just to say that you thought it was really good and needs no further improvement. Yeah, any comments that you would like to add. So with that, I'll say thanks again to everyone for attending. Thanks again, Marianne, and enjoy the rest of the day.
Thank you very much. Have a nice rest of the day. Bye.
Bye.